What's going on, you guys? Mr. Allen here. We got ourselves quite the wonderful, fantastic, loaded math problem here. We're given the graph of the polynomial function, and we got to find our max and mins, intervals of increasing and decreasing, and end behavior. And you know what? I'm going to add one more here. Let's get a little domain and range action going on at the end. All right. So max and mins. Let's talk about our max and mins here. So this guy right here is a high point. It'd be considered to be a relative maximum, right? It's not the absolute maximum. Our absolute max is going to be right here. That's going to be 1, 2, 3, up 2. So 3, 2. So that's our absolute max, but this is still considered to be a relative max. Meaning if I were just to isolate part of it, what's up? That would be a high point on that portion of the graph. All right, so let's write those two down. We got -4, 0, and we have 3, 2. That is my absolute maximum. Now for minimums, well, I've got one minimum right here. It looks like it's -1, -4. So -1, -4. That would be my minimum. All right. And now these max and mins are actually going to come in very handy when it comes to increasing and decreasing intervals, as well as my range. All right. So for increasing and decreasing, we look at these as if we're like riding a roller coaster from left to right. Okay. So if I'm going from left to right on this graph here, I'm going up the graph at first. So this would be an interval of increasing. Now, where does this graph start on the far left-hand side? That would be at -infinity. So I'm going to have one interval of increasing from -infinity to, well, when does it change direction? It changes direction when x equals -4. These are my x values that I'm writing here in the parentheses in my interval notation, all right? When I'm saying it's increasing, I'm talking about the y values, what it's doing going up and down, but I'm saying when it's happening with my x values, which are these guys, all right? Now we're going to turn, and now I'm going down, yelling timber. Great joke. All right, from -4 to, well, my x value is going to be -1 there. So decreasing from -4 to -1. All right, then I'm going to turn direction again, and now I'm moving up the graph. From, we'll union that bad boy, from -1 to what value? Well, +3 is now my x value. So between -1 and 3, my graph is increasing. And then what happens at that maximum, that absolute maximum? It turns again, and now it's going down. Once again, yelling timber. All right, so decreasing again, union with that bad boy. So from my x value of 3 to what's on the far right-hand side? Oh, infinity, +infinity. It's going down, it's yelling timber, it's decreasing. All right, so there's our intervals of increasing, there's our intervals of decreasing. I find it easy to set these two things up and just work my way from left to right. Okay, writing those intervals. Next thing, end behavior, meaning what's it doing on the ends of the graph? These two are easily confused and mixed up, okay? All I'm looking at for end behavior here, the only thing I want to look at for end behavior are my arrows, the arrows on the graph. So as x goes to -infinity, as I go to the left side of the graph, what's f of x doing? It's going down to -infinity. Beautiful. On the right side of the graph, as I go to +infinity, as I go further and further right, this graph just keeps going down. That'd be negative infinity for that one right there. All right, so for both of them, they are -infinity. Some observations we may make is that, oh, when the end behavior is the same, it's an even function, an even degree function, right? This is a quartic as we see it right now. There could be some other things going on, but quartic would be what I would say for this one here. It's an even degree. They're both going down or they're both going up. In this case, going down. All right, now domain and range. The domain for any polynomial function is going to be all real numbers. Whether you write it like that, or you could write it from -infinity to +infinity if you like to use interval notation. Either one of these would be great. They are not both needed, just one or the other unless specified, okay? Now for my range is restricted when we have an even degree function because there's going to be some high point or some low point. In this case, we have that high point, right? What is my y value at that high point? It's 2. So the highest this graph is going to get is +2, but it's going to keep on going down. So to match notations here, this would be y is less than or equal to +2. That would be my range. Way you can write that in interval notation is from -infinity to +2, and I would use a bracket here because I'm including that 2 in my range restriction. Man, dude, that's dope. That's awesome. All sorts of fun little colors going on here. All right, a lot of good stuff there. A lot of dope stuff there. Hope you guys enjoyed it as much as I did. I'll see you guys later. Have a good one. Deuces.